Welcome back, everybody. We're going to do another example here, and the example we're going to do is an observational study. In the previous video, we did an experimental study, and if you remember, we learned about the difference between an experimental study and an observational study at the beginning of this module a couple of videos ago. And so an experimental study, one or more factors are controlled so that data can be obtained about how the factors influence the variables of interest. And in an observational study, no attempt is made to control the factors. So we're going to explore that just a little bit here right in the beginning. And we learned when we were doing all this, we learned about the difference between factor and treatment and experimental units and completely randomized design and outcomes. So you have a factor, which you can also think of also known as a treatment. And I think this example coming up actually makes a really nice distinction between a factor and a treatment. But the factor might be, diet, and then the treatment would be different types of diets, right? So it's kind of like I think about a treatment as sort of a subcategory of the factor, or it's the factor broken down into smaller pieces. So the factor might be like we're gonna, have a diet, and the treatment would be the different types of diet, and we apply those treatments to our experimental units. And so in this little example, we'd be applying different diets, different treatments to different people to measure an outcome, a variable of interest. And in this scenario, it would be weight loss. And weight loss, we'd be looking to see which treatment, which diet creates the greatest weight loss for people. And when we randomly assign the treatments to the experimental units, the diets to the people, that's called completely randomized design. And so here's where all that's described: factor, treatment, experimental units, completely randomized design. You could pause the video, you could take a gander through that, and then when you're done, you could pause the video here and you could kind of think about these two in relation to each other. And so we talked about, that statistical studies can be classified as being either experimental or observational. And in an experimental study, one or more factors are controlled so that data can be obtained about how the factors influence the variables of interest, right? So one or more factors are controlled. We're controlling the factor, which diet is, which diets are we looking at, and how does that influence our variable of interest, our outcome? And so in the first problem that we did, the first problem we did was an experimental study where we're controlling factors. And if we come down here and we take a look at that first problem, which is right here, we did the Chematech. And so that was like the last couple of videos, the last two videos. And in this, they developed a new filtration system. There are different methods that can be used to assemble the system. They narrowed down to 3 methods, A, B, and C. They wanted to determine which method produces the greatest number of systems per week. For the purpose, they selected 15 workers, then randomly assigned 3 treatments to 5 of the workers. 3 treatments to 5 of the workers. And so here, if you think about this, what's like the dependent variable, what's the independent variable, the factor, and what the outcome that we're looking to measure. So if we go back to this diagram, right, the outcome that we're looking to measure, and I'm just going to copy this slide actually so I could reference it pretty easily. We'll just have it close at hand. Control C, and then bring it up here and drop it right beneath there. Control V. So now we could flip between these 2 slides real easily. So the outcome we're wanting to measure is like how many get assembled each week. What's the number of filtrations assembled per week? And so here we have the number of filtration systems assembled per week. I was actually looking at this incorrectly. I thought this was time of assembly when I was doing the previous ones, in which case, right, this one is grabbing my eye. You get the most systems and you have the least variance. So that's a better way that B would be the better solution out of all of those. But, makes no difference in the way I was explaining it earlier in terms of the analysis. The independent variable, the outcome, the dependent variable, the outcome, the dependent variable, the response variable, the outcome, AKA, all those are synonymous. You could say, hey, the outcome, or you could also say, hey, the dependent variable, or you could also say, hey, the response variable, and you can leave out the hey part. But dependent variable, response variable, and outcome, all synonymous. And the outcome, dependent variable, response variable that we're looking for is how many units were assembled, right? And so there's going to be something, and the experimental units are workers, And then we're applying different treatments, and the different treatments we're applying are A, B, and C, right? So we're designing this experiment, and we're having each worker, right? Each worker work with each method and see how many units get produced. And so the factor is the assembly method. So here, factor, or the factor is the assembly method. That's good. And then the treatment, the independent variables are A, B, and C. And then the experimental units are the employees, and the response unit, the dependent variable, is the number of units produced. Number of units produced, response unit, dependent variable, outcome. So that's like a really good little summary of these terms right here, and that's an example. And we're learning this because that's an experimental study. One or more factors are controlled. What are the factors that are controlled? The factors are the assembly method. We're controlling which treatments, which factors, which independent variables are being applied to the experimental units, the workers, to see what the outcome is, what the response unit, the dependent variable is, right? Like how many units to get produced. So now we're going to move into a new problem. This new problem is way down here in our slides. Here's the new problem. I'm going to copy it, and I'm just going to bring it up here and drop it next to the ones that we were just looking at, which are right here, and then I'll delete these so the slide deck stays in order. All right, so with this one here, we're going to read it in just 1 second. I just had the fear that I did Control X instead of Control C, but no, there it is. It's still right there. So boom, it's there, and it's boom, also right here, right there. There we go. So for this example, NCP manufactures printers and fax machines at plants located in Atlanta, Dallas, and Seattle. I didn't know people still manufactured fax machines. To measure how much employees at each plant, each of the plants, statisticians and English don't go well together. To measure how much employees at each of the plants know about quality management, a random sample of 6 employees was selected from each plant, and the employees selected were given quality awareness examination. Managers want to know if there is significant difference in the mean examination score for the employees at 3 plants. An F-test will be conducted using alpha equal to 0.05. And so this is an observational study, right? This was an experimental study where we have treatments A, B, and C, and we're applying those treatments to experimental units, and then we're seeing how that affects outcomes. And we're trying to create some connection between the treatment that is applied and the outcomes to see which treatment creates the best outcomes, right? And then here, we're just sort of observing. This is an observational study. We're observing the current state of things. What are things like now? We're just randomly selecting employees, and we're just measuring them, right? We're just giving them an examination. So plant employee selector, we're given a quality awareness examination, right? We're just giving them an examination. We're assessing them. We're observing where they're at right now. And so managers want to know if there's significant difference between the examination score, the mean examination score, for employees at the different plants, right? At the 3 plants. Difference in those scores for employees at the 3 different plants. So it's an observational study. So that's just to illustrate the difference between an experimental study, one where more factors are controlled. So the data is obtained about how the factors influence the variable of interest, aka the variable of interest is also the dependent variable, the response unit. And then also, because we want to see how the factors influence the outcomes, right? And how many get assembled in a week. That's the variable of interest. That's the response variable. That's the response unit, the dependent variable, and it's also known as the outcome. So lots of words for the same thing. In an observational study, no attempt is made to control the factors, right? So we're not making an attempt to control the factors here. Right? We have a factor, quality awareness. We're not making an attempt. And the treatments are Atlanta, Dallas, and Seattle. And that's the independent variable. And the experimental units are the employees. And the response units are the examination score, the dependent variable, right? That's also the variable of interest. We'll just put that here. And 1, 2, 3, 4, 5. Variable of interest, okay? And so all of that is there, and that's just a little bit of the terminology. And so no attempt with an observational study is made to control the factors. And so just pause this video here for a second, and think about that, and think about how no attempt, let's just get that phrase right here. We'll copy that, Control C, and we'll bring that over here, and we'll do a Control V, and we'll stretch that out, get it into one line, and bring it down, and let's make it smaller. Let's make it like 10, and now let's just bring it down a little bit more. So in an observational study, no attempt is made to control the factors. So pause this video here and just think about that and read the example and think about how no attempt is made to control the factors. So go ahead and pause the video and think about that for a moment. All right, so I just paused the video and I also thought about it. And in this previous one, right, which was not an observational study, it was the experimental study. And in this previous one, the factors, an attempt was made to control the factors, or they did control the factors. They said, hey, assembly method A, assembly method B, assembly method C, right? And so they're controlling the factors, the treatments, then they're applying those to experimental units, and they're seeing how those treatments that they are consciously controlling, selecting, designing 3 different assembly methods, how it influences the outcomes, how many units are produced. So that's where the factors are controlled. Right? Here in an observational study, no attempt is made to control the factors. And so here it says the factor is quality awareness. Are they like architecting or engineering or like, coming up with different treatments to see if like, they could control, how good people are with quality in the plant? They're not. So the factor is just quality awareness, and the treatments are just like, we're going to look at it at Atlanta, Dallas, and Seattle, and that's an independent variable, right? And there's nothing that's being done to try to control like the factor or the treatments. It's not like in this example where they're like, we have assembly method A, B, and C, and they consciously put together different assembly methods, and they're controlling those factors, those treatments. Here, it's just like the factors, quality awareness, the treatments, the sub kind of category of factors is like, we're going to look at quality awareness in Atlanta, Dallas, and Seattle. And the experimental units, we're looking at that in relation to the employees. So kind of what is being applied to each employee, if we go back here, the experimental units, the employees, what's being applied to them is where are they at? Right? Are they in Atlanta? Are they in Dallas? Or are they in Seattle? Right? That's the treatment. Which one are they at? And then the outcome is we're just measuring. We're measuring their examination score. And so we're just seeing like where are they at. We're not trying to control how well they do on the exam. We're just randomly choosing people and giving them an exam. And that's the variable of interest. We're not trying to influence the variable of interest. Right? So it's just an observational study. And I don't feel like I explained that as well as I could, but I give myself at least a C quality explanation and maybe a B quality explanation. So hopefully that makes some sense to you. All right, so this is an introduction to an observational study and testing for the quality of K population means. In the next video, we're going to jump in and see how to solve this. And we're also going to see a little anomaly between the more thorough way to solve this when we do some calculations, and then also a formula, which is a more cursory way, a less thorough way, a more cursory way to solve it that ChatGPT forwarded. So we'll see that in the next video. See you in the next video.